Good morning students. So in today's video we are going to learn about redox reactions, what is meant by redox reaction, okay, different examples and types of redox reactions. Okay, now how to identify whether a given equation is redox or not, all those we are going to learn in this video. So redox reactions, actually the type of reactions in which oxidation as well as reduction takes place both simultaneously, then such kind of reactions are called as redox reactions. So before we have to learn about the actual definition of redox reactions, we have to learn what is oxidation, what is reduction, and we have to learn certain examples for that, and we are going to learn how oxidation reaction how redox reactions will form. Okay, so once look at this definition for oxidation. For oxidation itself we have four definitions. Okay, now four definitions. First one, if it is if you go with first one, addition of oxygen is also called as oxidation. Addition of oxygen, here sulfur is added with oxygen. Oxygen is added to sulfur to form sulfur dioxide. S plus O2 gives rise to SO2. So here oxygen is added. So this reaction is called as oxidation reaction. Next, same like that, removal of hydrogen. If hydrogen is removed from any substance, okay, then also you can call it as oxidation only. See this example, H2S means hydrogen sulfide. When reacts with chlorine, it forms 2HCl plus S. That means here hydrogen is removed from H2S. Okay, now hydrogen is removed from H2S and elemental form of sulfur is formed. Okay, now same like that, addition of highly electronegative element. Okay, not only addition of oxygen, addition of highly electronegative element is also called as oxidation. Highly electronegative elements examples are what? Fluorine, oxygen, nitrogen, chlorine. Okay, now Pon-Cl elements. These Pon-Cl elements, if they are added, then also you can call it as oxidation reaction only. So here magnesium is there. To that magnesium, chlorine is added. Okay, now chlorine is highly electronegative element. So and it forms MgCl2. It forms ionic bond. Okay, now you all have learnt about ionic bond also. Okay, so addition of highly electronegative element is also termed as what? Oxidation reaction. And next, removal of highly electropositive element. I wrote here in short, En means electronegative, Ep means electropositive. Okay, now removal of highly electropositive element is also called as oxidation only. So here potassium iodide, Ki means what? Potassium iodide. When reacts with bromine, it forms KBr plus I2. Okay, now potassium is removed from potassium iodide. Okay, so potassium is comparatively highly electronegative. Okay, now in comparison with iodine, bromine and all. Okay, so removal of highly electropositive element is also termed as what? Oxidation reaction. Now coming to modern concept of oxidation. Okay, now what is modern concept of oxidation? Loss of electrons is also called as oxidation. Okay, now according to modern concept, loss of electrons is also called as oxidation. Okay, now loss of electrons is also called as oxidation. Okay, like for example, if you go with sodium metal, okay, sodium has 11 electrons. Nearest inert gas is argon. So to become stable like argon, sodium has to lose one electron and forms Na plus ion. So this process where losing of an electron, okay, takes place, if it takes place, then you can call that also as oxidation only. Okay, now according to modern concept, according to the modern definition of oxidation, okay, loss of electrons is also called as oxidation. So if electrons are lost from any element, then that process can also be termed as what? Oxidation. Okay, so please note down all these examples. Then we go for reduction. So let us learn about oxidant or oxidizing agent. What is meant by oxidant or oxidizing agent? A substance which undergoes reduction is called as oxidizing agent. Okay, now whichever the substance which undergoes reduction, you call it as oxidizing agent, and reverse process, like the substance which undergoes oxidation is called as reducing agent. Okay, so here if you go for the examples of oxidizing agents, fluorine is the best oxidizing agent, and other examples of oxidizing agents are KMnO4 means potassium permanganate and manganese dioxide, K2Cr2O7 means potassium dichromate, and HNO3 means nitric acid. So these are the best examples for oxidizing agents, okay now, or oxidants. Okay, next we proceed to reduction. 4 definitions are there for reduction also. Let us see the first one, removal of oxygen. You can call it as reduction. Removal of oxygen is also called as reduction. Here if you take for the example CuO plus C. Okay now, here coke, carbon can be taken as coke. Okay now, so coke acts as a reducing agent. Carbon from copper oxide, oxygen is removed. Okay now, and copper oxide turned to molten copper, Cu plus CO. Okay, so removal of oxygen is also reduction. And next, addition of hydrogen is also called as reduction only. C2H4, ethene. Ethene when reacts with hydrogen, it gives ethane. C2H6 means what? Ethane. Alkenes on hydrogenation gives alkanes. Okay, now you will learn this in organic chemistry also. Okay, and third definition is what? Removal of highly electronegative element. Okay, removal of highly electronegative element is also called as what? Reduction. Like FeCl3 is there when reacts with SnCl2, ferric chloride. Okay, when reacts with stannous chloride. Okay, so it has changed to FeCl2, which is means ferric chloride has been changed to ferrous chloride because of the addition of highly electronegative element. Okay, removal of highly electronegative element. Out of 3 chlorines, 1 chlorine has been removed and formed FeCl2. That's why this is also called as what? Reduction. Next, look at this, addition of electropositive element is also called as reduction. Here if you take the example, CuCl2 plus Cu gives rise to Cu2Cl2. Okay, now cuprous chloride, cuprous chloride, and this is cupric chloride. CuCl2 is cupric chloride, Cu2Cl2 is cuprous chloride. Copper is added to CuCl2. That's why it's a addition of highly electropositive element. EP means what? Electropositive element. Okay, so next, according to the modern concept of reduction, reduction is also called as gain of electrons. Okay, now like for example, aluminium ion Al plus 3 gains 3 electrons and forms molten aluminium. Okay, now suppose chlorine to get nearest inert gas configuration, it gains electrons and forms anion, Cl minus ion. Okay, so gaining of electrons, according to the modern concept, gaining of electrons is also called as reduction. Next, look at this, reductant. Reductant means a substance which undergoes oxidation is called reducing agent or also called as reductant. Okay, now reductant means electron donor. Okay, now gaining of electrons is called as reduction, and the substance which can gain electrons, you call it as reductant. Okay, now example, the process is called as what we call the process of gaining of electrons is called as reduction. The substance which loses electrons is called as reducing agent. Okay, now substance which loses electrons, metals loses electrons, so metals are good reducing agents. But here you have some examples of non-metals are also there which are considered as best reducing agents. Okay, like for example hydrogen is a non-metal but still it is a reducing agent. Okay, now coke means carbon in the form of coke. It is also a non-metal but still it acts as a reducing agent. Okay, now see here, in metals you can say that cesium is the best reducing agent, and in aqueous state lithium is considered as the best reducing agent. And if you go for the other examples of reducing agents, as I already told you, coke is the best reducing agent. H2S, hydrogen sulfide, is the best reducing agent, and LiAlH4 means lithium aluminum hydride. It is used as a reagent and a catalyst or a reducing agent in certain organic reactions. Okay, now lithium aluminum hydride, LiAlH4. Okay, so these are the examples for reducing agents. Okay, now please note down. So if you introduce redox reactions now, the reactions in which both oxidation and reduction takes place simultaneously are called as what? Redox reactions. Okay, now both oxidation and reduction takes place simultaneously. So whenever any reaction is given, it's very difficult to remember all the four definitions which we have learnt. Instead of identifying like addition of oxygen, removal of hydrogen, all those, we have a best way to identify the redox reactions by identifying the change in oxidation number. See, identification of oxidation and reduction using oxidation number. Okay, now see, what you have to remember is, if there is an increase in oxidation number from reactant side to product side, then you call that as oxidation. Suppose if there is a decrease in oxidation number from reactant side to product side, then you call it as reduction. Okay, now we already have learnt about oxidation numbers. So it's very easy for us to identify whether the reaction is having both reduction as well as oxidation, both are happening or not. Okay, by assigning oxidation numbers and comparing the oxidation numbers from reactant side to product side. Okay, let us verify these examples. Here one equation is given to you, like Zn plus CuSO4 gives rise to ZnSO4 plus Cu. Let us assign oxidation numbers for all these elements and compare the oxidation numbers from reactant side to product side. Okay, so zinc in its elemental state oxidation number is 0, and here for sulfate ion -2, and that's why for copper it will be +2. Similarly here also for sulfate ion -2, zinc it will be +2, and copper in elemental state, so it is 0. So after assigning oxidation numbers, let us compare the from where to where increase in oxidation number happens and where to where decrease in oxidation number happens. Okay, now see here, zinc, if you compare zinc from reactant side to product side, okay, oxidation number is increased from 0 to +2. Increased, oxidation number is increased. Okay, now increase in oxidation number, increase in ON, that means oxidation. Okay, now zinc is oxidized. Okay, same like that, if you compare copper from reactant side to product side, copper oxidation number changed from +2 to 0, means reduced, so it is reduction. Okay, so here the substance which undergoes oxidation is called as reducing agent, and the substance which undergoes reduction is called as oxidizing agent. So in the reactant side, whatever the substance which is getting oxidized, here zinc oxidation number changed from 0 to +2, that means there is an increase in oxidation number for only zinc. So you can write here, zinc is undergoing oxidation, so zinc is reducing agent. Here in this reaction, zinc is considered as reducing agent. Similarly, you are finding the change in oxidation number only for copper. Okay, in copper sulfate, copper is undergoing the change in oxidation number. So for that reason, you should not write only copper is getting reduced. No, copper sulfate is going to get reduced. Okay, now total compound name you should remember, you should write. Okay, now here you are finding the change in oxidation number only in copper. In sulfate there is no change in oxidation number. Even though you should not write only copper is acting as a reducing agent, oxidizing agent. Okay, total copper sulfate is acting as oxidizing agent. Okay, now so here you have to remember CuSO4, not only Cu. CuSO4 is oxidizing agent. Whatever the substances which are acting as oxidizing and reducing agents, they will be present only in reactant side. Okay, now after the product formation, whatever the substances which are so formed, products formed, you are not supposed to call them as oxidizing and reducing agents. Only the substances which are participating in the reaction can act as either oxidizing or reducing agent. This point you have to remember. Now let us go with the next example. I'll write it a little bit down, okay, because I need some space up and down to show the change in oxidation number. Okay, so let me write the equation once again. Okay, so here the equation is Cu plus 2 AgNO3. If I write here, you can see, I think, right? Cu plus 2 AgNO3 gives rise to 2Ag plus CuNO3 taken twice. 2Ag plus CuNO3 taken twice. This is the equation given to you. Now how to identify whether it is redox or not? Let us assign oxidation numbers for each and every element in the given equation. Copper in its elemental state, so it is 0. Nitrate ion -1. For Ag +1. For Ag here in product side, you are finding it in elemental state, so its oxidation number is 0. Nitrate ion -1. Here 2 nitrate ions are there, so copper will have +2. Now after assigning oxidation numbers, you identify the change in oxidation number. Okay, now copper from 0 to +2. Okay, copper oxidation number changed from 0 to +2. That means oxidation number is increased. Increase in oxidation number, you call it as oxidation. Okay, so copper is undergoing oxidation. So copper acts as what? Reducing agent. Similarly, you are finding the change in oxidation number in silver. Silver, if you compare, okay, my +1 to 0 means its oxidation number is reduced. Okay, that means it is reduction. Okay, so AgNO3, even though you are finding the change in oxidation number only in Ag, but you should call the whole AgNO3 is what we call oxidizing agent. Okay, so here you have to remember copper undergone oxidation. So copper is reducing agent. Copper acts as reducing agent. And AgNO3 में Ag has observed the change in oxidation number is observed in Ag, but still total AgNO3 acts as what? Oxidizing agent. AgNO3 acts as oxidizing agent. Okay, so like this you have to identify by assigning what? Oxidation numbers from reactant side to product side, and should compare if there is an increase in oxidation number of an element from reactant side to product side, then you call it as oxidation, and if there is a decrease in oxidation number from reactant side to product side, then you call it as reduction. Okay, so now accordingly you have to identify which is oxidizing agent and which is reducing agent also. Okay, so please note down. So now let us go for the types of redox reactions. You have mainly 5 types of redox reactions. First one is combination, second one decomposition, third one displacement, fourth one is disproportionation reaction, and fifth one is comproportionation reaction. These are the main types of redox reactions. So let us learn each one with examples. So first one in types of redox reaction, first one is combination reaction. In the name itself it is there, 2 or more substances combine to form a single product. Okay, so let us see some examples. First example, you all are very much aware of this, burning of magnesium ribbon. Okay, now magnesium ribbon, when it is burnt, okay, the equation will be like 2Mg plus O2 gives rise to 2MgO. Here 2 reactants are there and 1 product is there. That's why it comes under combination. Now is it redox or not? How to identify? We need to assign oxidation numbers. So magnesium elemental form, so 0. Oxygen also is in elemental form, so it is 0. Oxygen's oxidation number, normally in normal oxides it is -2, and magnesium second A group element, so first +2. So now if you compare the change in oxidation number, magnesium's oxidation number changed from 0 to +2 means oxidation. Increase in oxidation number is there, so it is oxidation. Okay, same like that, oxygen's oxidation number is changed from 0 to -2. Okay, now 0 to -2 means reduction. Okay, so here oxidation reduction both takes place simultaneously. That's why burning of magnesium ribbon, you can consider it as an example for what? Redox reaction. Now coming to formation of alumina. Alumina means Al2O3. Okay, now so 4Al plus 3O2 gives rise to 2Al2O3. Here also two reactants and 1 single product. Now let us identify whether it is redox or not. Aluminum elemental state 0. Oxygen also elemental state 0. Here oxygen -2, so aluminum will be +3. You check, if you are not able to write fast, you keep X and calculate, and pause the video, write the equations once again and check in your notebook whether increase is happening or decrease is happening. Okay, so aluminum from 0 to plus 3 means increase in oxidation is number is there, so it is called as oxidation. And oxygen's oxidation number is decreased from 0 to minus 2. Okay, now means reduction. So as oxidation and reduction takes place simultaneously, that's why you can call it as redox reaction. Okay, now, and very important note point, you can note that all combustion reactions in which oxidation number of oxygen changes from 0 to minus 2 are said to be redox. Okay, now if oxidation number of oxygen changes from 0 to minus 2 in any combustion reaction, if it happens, then compulsorily that particular combustion reactions are said to be redox. Let us see some one example for that. This side I am going to rub, and we are going to I am going to give an example for this note point. Okay. Now for this note point, let us consider this example. C2H4 is ethene. Ethene on combustion means reaction with oxygen. It forms carbon dioxide and water. Any hydrocarbon, when it is combusted, compulsorily carbon dioxide and water are the standard products which you are going to get. Compulsorily carbon dioxide and water are only formed. Okay, so this is an example for combustion reaction. Now let us take whether this note point is valid or not. If the oxidation number of oxygen changes from 0 to minus 2, then that combustion reaction is said to be redox. Let us verify. Carbon, suppose first for hydrogen if you take, it is plus 1. Okay, now if you don't know the carbon's oxidation number, let us keep it as X. So 2 into X plus 4 into plus 1 is equal to 0. So 2x plus 4 is equal to 0. 2x is equal to minus 4. X is equal to minus 2. So carbon ki ikkada oxidation number vachesi minus 2 we got it. Then oxygen is available in the elemental form. So you will take the oxidation number of oxygen is 0. And carbons is, oxygen is minus 2. So here carbons will be plus 4. And similarly oxygen is minus 2. So hydrogens will be plus 1. Okay, so these are the oxidation numbers which we have assigned. Now let us check the change in oxidation number. Okay, so here whether first let us check it is redox or not. Here carbon's oxidation number is changed from minus 2 to plus 4. Okay, now minus 2 to plus 4 means what? Increase is there. Increase in oxidation number is there. So it is oxidation. Okay, now verify the oxidation number from reactant side to product side in oxygen. Oxygen's oxidation number has been reduced from 0 to minus 2. So it is reduction. That's why it is redox reaction. Now the note point became valid or not, you have to check. Oxygen's oxidation number changed from 0 to minus 2. Okay, now here also 0 to minus 2, even if you take from here to here or as well as from here to here, anything you can consider. Okay, but from reactant side to product side you should check. Okay, so if oxidation number of oxygen is changed from 0 to minus 2, okay, then such combustion reactions comes under redox only. So this is an example for such kind of combustion reactions which is considered as redox. And please don't consider that all types of combustion reactions may not be redox also. Okay, all types of combustion reactions can be oxidation reactions, but it's not always redox. Okay, sometimes it can be taken as oxidation reaction, but always it cannot be redox. That's why if it has to be redox means what you should observe, the oxidation number of oxygen must change from 0 to minus 2. Then only such kind of combustion reactions are only redox. Okay, so please note down. Now let us learn about the second type of redox reaction, that is decomposition reaction. What is meant by decomposition reactions? The reactions in which single substance splits into two or more substances. You call them as decomposition reaction. Let us learn the examples. So if you go with the first example, let us assign oxidation numbers for each and every element in reactant side as well as product side. Okay, now oxygen minus 2, chlorine minus 1, potassium plus 1. Okay, potassium plus 1, chlorine we don't know, so let us keep it as X. So 1 into plus 1 plus 3 into minus 2 plus 1 into X is equal to 0. So 1 plus 1 3 into 2 minus 6 plus x is equal to 0. So minus 6 plus 1, which is equal to what? X minus 5 is equal to 0. That means x is equal to 5. So oxidation number of chlorine in KClO3 is plus 5. Okay. So now coming to product side, minus 1 plus 1, and oxygen is in elemental state, so it is 0. Okay, so down this calculation I am rubbing. Okay, so now if you compare the change in oxidation number from reactant side to product side. Okay, so only chlorine's oxidation number has been changed. Not only chlorine and oxygen both. Here 5 to minus 1. Okay, now 5 to minus 1 means reduction. Okay, now 5 to minus 1 means reduction. Oxygen's oxidation number changed from minus 2 to 0. Minus 2 to 0 means there is an increase in oxidation number, so you call it as oxidation. If there is an increase in oxidation number, you call it as oxidation. Okay, so this is an example for decomposition as well as redox also. Now let us see one more example. HGO. Hydrogen is minus 2, so mercury it will be plus 1, and both here are in elemental state, so 0 0. Now coming to the change in oxidation number, hydrogen oxidation number changed from 0 to plus 2 to 0, so reduction. Okay, now reduced in oxidation number, so reduction, and oxygen's oxidation number changed from minus 2 to 0. Minus 2 to 0 means increase in oxidation number, so you call it as oxidation. As both of them occur simultaneously, that's why you can call it as redox. Okay, now so here HGO acts as what? Here only one reactant substance is there, so that itself will act as oxidizing as well as reducing agent. Okay, now that itself will act as both oxidizing as well as reducing agent in that reaction. Okay, now given one note point, decomposition reactions are said to be redox if and only if. IFF means what? If and only if the products formed are in elemental state. Okay, now if the product formed is in elemental state, see here, when decomposition of HGO is done, you got the products both here are in elemental state only. Then such kind of decomposition reactions are compulsorily redox. Even in this example also, 2 KClO3 gives rise to 2 KCl plus 3O2. Here oxygen is attained in elemental state. That's why you can take such decomposition reactions are redox. Now coming to this example. Okay, now let us assign oxidation numbers. Calcium plus 2, totally carbonate ion minus 2. Okay, now calcium plus 2, oxygen minus 2. Okay, now oxygen minus 2, carbon plus 4. Okay, or if you can directly check, oxygen minus 2, so carbon will be 1 into 2 plus 1 into x plus 3 into minus 2 is equal to 0. So 2 plus x minus 6 is equal to 0. Means x minus 4 is equal to 0, x is equal to 4. Okay, so carbon's oxidation number is plus 4. Now you observe the change in oxidation number from reactant side to product side. Okay, now reactant side nunchi product side ki change in oxidation number observe cheyandi. Calcium is plus 2, calcium here also plus 2. Carbon plus 4, here also plus 4. Oxygen minus 2, here also oxygen minus 2. That means there is no change in oxidation number. Okay, now there is no change in oxidation number. So if there is no change in oxidation number, okay, now there is no change in oxidation number, change in ON. ON means oxidation number. So then we cannot call it as redox. It is an example for decomposition only, but it is not called as redox because there is no change in oxidation number from reactant side to product side. Okay, so please note down. Hence, all decomposition reactions cannot be redox. The decomposition reactions are said to be redox if and only if the product formed on the product side should be in elemental state. Okay, so please note down that point. Now let us move on to the third type of displacement reactions, redox. Okay, in that displacement reactions, again we have two types, metal displacement reactions and non-metal displacement reactions. So actually displacement reactions, if you go for the metal displacement reactions, highly reactive metal or active metals can displace less reactive metals from their salt solutions. Okay na, highly reactive metals maatrame less reactive metals ni displace cheyagalavu. Okay na, so you need to know about reactivity series for this, okay, which you have already learned about that in your NCRT. ఓకే, సో ఇప్పుడు ఇక్కడ ఇచ్చిన ఈక్వేషన్ ఒకటి ఎగ్జాంపుల్ చూద్దాం. అల్యూమినోథర్మీ ప్రాసెస్ ఆర్ థర్మైట్ వెల్డింగ్ ప్రాసెస్. సో ఇక్కడ ఈక్వేషన్ వచ్చేసి 8Al + 3Fe3O4 గివ్స్ రైస్ టు 9Fe + 4Al2O3. ఈక్వేషన్ బ్యాలెన్స్డ్ ఈక్వేషన్ వాళ్ళు ఇచ్చేస్తారు. ఓకే, యూ నీడ్ టు అసైన్ ఆక్సిడేషన్ నెంబర్స్. ఇక్కడ అల్యూమినియం ఎలిమెంటల్ స్టేట్ కాబట్టి 0, ఆక్సిజన్కి -2 ఉంటే ఐరన్కి ఎంత ఉంటుంది ఇక్కడ? See here, 3 into x plus 4 into -2 is equal to 0. So 3x minus 8 is equal to 0. ఇది మిక్స్డ్ ఆక్సైడ్ అని మనం చదువుకున్నాం. సో 3x is equal to 8. That implies x is equal to 8/3 ఉంది. ఓకేనా? సో ఆక్సిజన్స్ ఆక్సిడేషన్ నెంబర్ -2 అయితే ఇక్కడ ఐరన్స్ ఆక్సిడేషన్ నెంబర్ is 8/3. ఓకేనా? Iron's oxidation number is 8/3. Now here iron's oxidation number elemental state లో ఉంది కాబట్టి 0. ఇక్కడ ఆక్సిజన్కి -2, అల్యూమినియంకి +3. ఓకే, సో 8/3 అంటే ఇట్ ఈస్ ఆల్మోస్ట్ అరౌండ్ 2.6, isn't it? 8/3 means it's almost around 2.6. సో ఇప్పుడు కంపేర్ చేసుకుంటే అల్యూమినియం ఆక్సిడేషన్ నెంబర్ చేంజ్ ఫ్రమ్ 0 to +3. ఓకేనా, 0 to +3. Okay, that means oxidation happened here. Okay, so now you compare oxidation number of iron అంటే 2.6 నుంచి 0 ఉంది, means reduction. ఓకేనా, 2.6 to 0, that's why it is reduction. Since both oxidation and reduction both took place, that's why this kind of displacement reactions, all type of displacement reactions are redox only. Okay na, metal displacement reactions, non-metal displacement reaction, or reduction of removal of hydrogen, or reaction of acids with metals where hydrogen liberation is happening. Such all reactions comes under displacement reactions, and all displacement reactions are redox reactions. Now let us see one example for non-metal displacement. Here the reaction is in between F2 and KBr. Here fluorine is more reactive non-metal in comparison with bromine. That's why fluorine, highly reactive non-metal, can displace less reactive non-metal from its salt solution. Okay, assign చేసి చూద్దాం. ఆక్సిడేషన్ నెంబర్ ఆఫ్ ఫ్లోరిన్ ఎలిమెంటల్ స్టేట్లో ఉంది కాబట్టి 0. హియర్ పొటాషియం +1, బ్రోమిన్ -1. ఇక్కడ బ్రోమిన్ ఎలిమెంటల్ స్టేట్లో ఉంది కాబట్టి 0. ఓకే, పొటాషియం +1, ఫ్లోరిన్ -1. నౌ వెరిఫై ద చేంజ్ ఇన్ ఆక్సిడేషన్ నెంబర్. ఫ్లోరిన్స్ ఆక్సిడేషన్ నెంబర్ చేంజ్ from 0 to -1 అంటే రిడక్షన్, తగ్గిపోయింది, రెడ్యూస్ అయిపోయింది. సో ఇట్ ఈస్ రిడక్షన్. నౌ బ్రోమిన్స్ ఆక్సిడేషన్ నెంబర్ చేంజ్ from -1 to 0. ఓకేనా, -1 to 0 means there is an increase in oxidation number. So it is considered as oxidation. As both oxidation and reduction takes place simultaneously, you can call this as an example for displacement as well as redox also. So this is an example for metal displacement, and this is one example for non-metal displacement. Okay, now let us see one example where displacement of metals with water or with metals with acids, if it takes place, how whether it is redox or not, let us check. Okay, so sodium metal with water, let us check. That's the most frequent reaction. So equation is 2Na plus 2H2O gives rise to. Okay, now third example, example 3, it's not metal displacement and all, just displacement of hydrogen from water molecule. Okay, so sodium metal when dissolved in water, I'll write it a little bit down so that I need to draw lines for representing the change. Sodium metal water lo vesam, 2Na plus 2H2O gives rise to 2NaOH plus H2. Okay, so this is the equation. Now let us identify whether it is redox or not. assign oxidation numbers on both sides. సోడియం ఎలిమెంటల్ స్టేట్లో ఉంది కాబట్టి 0, వాటర్లో ఆక్సిజన్కి -2, హైడ్రోజన్కి +1. ఓకే, ఇక్కడ సోడియం +1, హైడ్రోజన్ +1, ఆక్సిజన్ -2 అండ్ హైడ్రోజన్ ఈజ్ 0. ఎలిమెంటల్ ఫామ్లో ఉంది కాబట్టి 0. నౌ యూ అబ్జర్వ్ ద చేంజ్ ఇన్ ఆక్సిడేషన్ నంబర్ ఫర్ సోడియం 0 to +1 means increase in oxidation number is there, so it is oxidation. There is an increase in oxidation number, so it is oxidation. Now if you observe change in oxidation number for hydrogen +1 to 0, okay, now +1 to 0 means it is reduced, so you call it as reduction. That means sodium metal reaction with water, it's a very vigorous reaction and it's a displacement reaction. Okay na, అది metal displacement కాదు, non metal displacement కూడా కాదు. Okay na, displacement of hydrogen from water, it has been took place, but still it's a displacement reaction and it is redox also. Okay, so please note down this. So next we will go for the very important type of redox reaction, that is disproportionation reaction. సో ఇక్కడ ఏంటంటే సేమ్ ఎలిమెంట్ విల్ అండర్గో బోత్ ఆక్సిడేషన్ అండ్ రిడక్షన్ సైమల్టేనియస్లీ. ఒకే ఎలిమెంట్ ఆక్సిడైజ్ అవుతుంది, రెడ్యూస్ అవుతుంది. ఓకేనా, అంటే ఒక కాంపౌండ్లో ఉండే ఒకే ఎలిమెంట్ విల్ హ్యావ్ ఇంక్రీజ్ ఇన్ ఆక్సిడేషన్ నంబర్ యాజ్ వెల్ యాజ్ డిక్రీజ్ ఇన్ ఆక్సిడేషన్ నంబర్. సో ఇలాంటి టైప్ ఆఫ్ డిస్ప్రపోర్షనేషన్ రియాక్షన్స్ అనేవి ఎప్పుడు పాసిబుల్ అవుతాయి అంటే ఇట్ ఈస్ పాసిబుల్ ఓన్లీ ఇఫ్ అండ్ ఓన్లీ ఇఫ్ ద ఎలిమెంట్ ఎగ్జిబిట్స్ ఎ మినిమమ్ ఆఫ్ 3 ఆక్సిడేషన్ నంబర్స్. ఒక ఎలిమెంట్ మినిమంగా 3 ఆక్సిడేషన్ నంబర్స్ ఎగ్జిబిట్ చేయగలిగితే అప్పుడే డిస్ప్రపోర్షనేషన్ అనేది జరుగుతుందన్నమాట. నౌ లెట్ us see the examples. Okay, now see the first equation which is given to you. P4 plus 3 NaOH gives rise to 3 NaOH plus water gives rise to pH3 means phosphine plus sodium hypophosphate, that is NaH2PO2. So ఇక్కడ ఎలిమెంటల్ స్టేట్ కాబట్టి P4కి 0, sodium +1, oxygen -2, hydrogen +1, oxygen -2, hydrogen +1, here hydrogen +1, so phosphorus -3 and oxygen -2, sodium +1, hydrogen +1. అప్పుడు ఫాస్ఫరస్కి ఎంత అవుతుందో క్యాలిక్యులేట్ చేద్దాం. 1 into +1 plus 2 into +1 plus 1 into x plus 2 into -2 is equal to 0. అంటే 1 plus 2 plus x minus 4 is equal to 0. 1 plus 2 అనేది 3, 3 minus 4 is -1. So phosphorus oxidation state is +1 here. ఓకే, సో ఇక్కడ ఈ క్యాలిక్యులేషన్ పార్ట్ నేను రఫ్ చేస్తున్నాను. వన్స్ చెక్ ఇట్ కేర్ఫుల్లీ, యూ డూ ఇట్ ఇన్ యువర్ రఫ్ అండ్ రైట్ ఇట్ ఫేర్ అగైన్. ఓకే, సో ఇప్పుడు కంపేర్ చేయండి ఆక్సిడేషన్ స్టేట్స్. ఫాస్ఫరస్ ఆక్సిడేషన్ స్టేట్ చేంజ్ ఫ్రమ్ 0 to -3, 0 to -3 అంటే రిడక్షన్ జరిగింది. అదే సేమ్ ఫాస్ఫరస్ ఆక్సిడేషన్ నంబర్ చేంజ్ ఫ్రమ్ 0 to +1 ఆల్సో, 0 to +1 అంటే ఇంక్రీజ్ ఇన్ ఆక్సిడేషన్ నంబర్, సో ఇట్ ఈస్ ఆక్సిడేషన్. సో ఆక్సిడేషన్ రిడక్షన్ టుక్ ప్లేస్ సైమల్టేనియస్లీ, ఓకే, బై ద సేమ్ ఎలిమెంట్. దట్స్ వై ఇట్ ఈస్ అన్ ఎగ్జాంపుల్ ఫర్ డిస్ప్రపోర్షనేషన్ రియాక్షన్. అంటే సింగిల్ ఆక్సిడేషన్ స్టేట్ రియాక్టెంట్ సైడ్లో ఇట్ ఈస్ స్ప్లిట్టింగ్ ఇంటూ డిఫరెంట్ ఆక్సిడేషన్ స్టేట్ ఫర్ ద సేమ్ ఎలిమెంట్. ఓకేనా, రియాక్టెంట్ సైడ్లో సింగిల్ ఆక్సిడేషన్ స్టేట్ ఉండాలి, ప్రోడక్ట్ సైడ్లో డిఫరెంట్ ఎలిమెంట్స్ డిఫరెంట్ కాంపౌండ్స్లో సేమ్ ఎలిమెంట్కి డిఫరెంట్ ఆక్సిడేషన్ స్టేట్స్ ఉండాలి. ఓకే, దెన్ యూ కెన్ కాల్ ఇట్ యాజ్ అన్ ఎగ్జాంపుల్ ఫర్ డిస్ప్రపోర్షనేషన్ రియాక్షన్. సేమ్ లైక్ దట్ క్లోరిన్ plus 2 NaOH gives rise to NaClO plus NaCl plus H2O. Chlorine elemental state 0, hydrogen +1, oxygen -2, sodium +1. ఇక్కడ కూడా సోడియం +1, ఆక్సిజన్ -2. అప్పుడు క్లోరిన్కి ఎంత అవుతుంది, x వేసుకుంటే, సో 1 into +1 plus 1 into -2 plus 1 into x is equal to 0. సో 1 - 2 plus x is equal to 0 అంటే x - 1 is equal to 0. సో x equal to 1. ఓకే, సో ఇక్కడ క్లోరిన్కి ఆక్సిడేషన్ నంబర్ +1 వచ్చింది. అలాగే ఇక్కడ సోడియంకి +1, క్లోరిన్కి -2, ఆక్సిజన్కి -2, హైడ్రోజన్కి +1. నౌ లెట్ us కంపేర్ ద ఆక్సిడేషన్ నంబర్ చేంజ్ ఇన్ రియాక్టెంట్ సైడ్ అండ్ ప్రోడక్ట్ సైడ్. క్లోరిన్ ఆక్సిడేషన్ నంబర్ చేంజ్ ఫ్రమ్ 0 to +1, ఓకేనా 0 to +1 అంటే ఆక్సిడేషన్. ఓకేనా, దెర్ ఈస్ అన్ ఇంక్రీజ్ ఇన్ ఆక్సిడేషన్ నెంబర్. సేమ్ క్లోరిన్కి ఆక్సిడేషన్ నెంబర్ చేంజ్ ఫ్రమ్ 0 to -1 కూడా. 0 to -1 అంటే రిడక్షన్. సో సేమ్ ఎలిమెంట్ ఈజ్ అండర్గోయింగ్ బోత్, same element chlorine is undergoing both oxidation as well as reduction. That's why it is an example for disproportionation reaction. So please note down. Finally we have last type of redox reaction, that is comproportionation reaction. It is just opposite of disproportionation reaction. మనం డిస్ప్రపోర్షనేషన్లో ఏం చూసాం, రియాక్టెంట్ సైడ్లో ఒక ఎలిమెంట్కి ఒకే ఒక ఆక్సిడేషన్ స్టేట్ ఉంది, ప్రోడక్ట్ సైడ్ వెళ్ళేసరికి స్ప్లిట్ అయ్యి డిఫరెంట్ కాంపౌండ్స్లో సేమ్ ఎలిమెంట్కి డిఫరెంట్ ఆక్సిడేషన్ స్టేట్స్ అనేవి కనిపించాయి మనకి. అంటే అదొక స్ప్లిట్టింగ్ రియాక్షన్ అనమాట. డిస్ప్రపోర్షనేషన్ ఏంటంటే రియాక్టెంట్ సైడ్లో ఒక ఆక్సిడేషన్ నెంబరు ఒక ఎలిమెంట్కి ఉంటే ప్రోడక్ట్ సైడ్లో అదే ఎలిమెంట్కి డిఫరెంట్ ఆక్సిడేషన్ స్టేట్, అంటే సింగిల్ ఆక్సిడేషన్ స్టేట్ స్ప్లిట్స్ ఇంటూ మెనీ ఆక్సిడేషన్ స్టేట్. ఓకే, దెన్ యూ కెన్ కాల్ ఇట్ as డిస్ప్రపోర్షనేషన్. జస్ట్ ఆపోజిట్ అయితే ఇప్పుడు మనకి కాంప్రపోర్షనేషన్లో ఏముంటుందంటే రియాక్టెంట్ సైడ్ మెనీ ఆక్సిడేషన్ స్టేట్స్ విల్ బి దేర్, బట్ ప్రోడక్ట్ సైడ్ ఓన్లీ వన్ ఆక్సిడేషన్ స్టేట్ విల్ బి దేర్ ఫర్ ద సేమ్ ఎలిమెంట్. ఓకేనా, అంటే కాంబినేషన్ లాగా అనమాట. ఓకేనా, ఇట్స్ లైక్ అ కాంబినేషన్ రియాక్షన్. చూడండి ఇక్కడ కాంబినేషన్ ప్రోడక్ట్లే ఉన్నాయి, అన్ని కాంబినేషన్ రియాక్షన్స్. ఓకేనా, డిస్ప్రపోర్షనేషన్లో ఏంటంటే రియాక్టెంట్ సైడ్ సింగిల్ ఆక్సిడేషన్ స్టేట్ ఉంటుంది, అదే ఎలిమెంట్కి ప్రోడక్ట్ సైడ్లో డిఫరెంట్ ఆక్సిడేషన్ స్టేట్స్ ఉంటాయి. కానీ కాంప్రపోర్షనేషన్కి రియాక్టెంట్ సైడ్ మాత్రం డిఫరెంట్ ఆక్సిడేషన్ స్టేట్స్ ఉంటాయి, అదే ఎలిమెంట్కి ప్రోడక్ట్ సైడ్ ఒకటే ఆక్సిడేషన్ స్టేట్ ఉంటుంది, సింగిల్. అంటే కాంప్రపోర్షనేషన్ ఈజ్ అ కాంబినేషన్ రియాక్షన్. మీరు అన్న వర్డ్లో కాంబినేషన్ అనేది గుర్తుపెట్టుకుంటే మీకు ఐడియాగా ఐడెంటిఫై చేసుకోవచ్చు. నా లెట్ us assign ఆక్సిడేషన్ స్టేట్స్ ఫర్ ఈచ్ అండ్ ఎవ్రీ ఎలిమెంట్. హియర్ సల్ఫేట్ అయాన్కి -2 ఉంటే సిల్వర్కి +2 ఉంటుంది. హియర్ సిల్వర్ ఈజ్ అన్ ఎలిమెంటల్ స్టేట్, సో 0. ఇక్కడ సల్ఫేట్ అయాన్కి -2 అయితే ఇక్కడ 2 సిల్వర్స్ ఉన్నాయి కాబట్టి +1 ఉంటుంది. ఓకే, నౌ యూ ఐడెంటిఫై ద చేంజ్ ఇన్ ఆక్సిడేషన్ నంబర్ Ag ఫ్రమ్ +2 to +1. +2 to +1 అంటే రిడక్షన్. ఓకే, పైన ప్లేస్ తక్కువ ఉంది కాబట్టి కిందే రాస్తున్నాను మళ్ళీ. అండ్ సిల్వర్ ఆక్సిడేషన్ నెంబర్ చేంజ్ ఫ్రమ్ 0 to +1 ఆల్సో. 0 to +1 అంటే ఆక్సిడేషన్. అంటే ఒకే ఎలిమెంట్ రియాక్టెంట్ సైడ్ ప్రోడక్ట్ సైడ్ ఒకే ఎలిమెంట్కి చేంజ్ ఇన్ ఆక్సిడేషన్ నెంబర్ అనేది మనకి చూసామన్నమాట. సేమ్ ఎలిమెంట్ ఈజ్ అండర్గోయింగ్, బట్ రియాక్టెంట్ సైడ్లో 2 ఆక్సిడేషన్ స్టేట్స్, ప్రోడక్ట్ సైడ్లో ఒకటే ఆక్సిడేషన్ స్టేట్ ఉంది. ఓకేనా, కంబైన్ అయిపోయి ఒకటే ఆక్సిడేషన్ స్టేట్ వచ్చింది. ఓకే, సచ్ రియాక్షన్స్ ఆర్ కాల్డ్ ఎస్ కాంప్రపోర్షనేషన్. కాంబినేషన్ అంటే కాంబినేషన్ రియాక్షన్స్ అవి. ఓకే, ఇక్కడ కూడా చూడండి, ఫర్ కార్బన్ ఎలిమెంటల్ స్టేట్ 0, ఆక్సిజన్ -2, కార్బన్ +4. ఇక్కడ కూడా ఆక్సిజన్ -2, కార్బన్ +2. ఓకే, కార్బన్ ఈజ్ అండర్గోయింగ్ ఆక్సిడేషన్ చేంజ్ ఫ్రమ్ 0 to +2 అంటే ఆక్సిడేషన్. అలాగే సేమ్ కార్బన్ ఈజ్ అండర్గోయింగ్ 0 to -2, లేకపోతే ఇక్కడ +4 to -2 తీసుకున్నా మీకు అది రిడక్షన్ కిందే వస్తుంది. 0 to -2 విచ్ ఈస్ కాల్డ్ యాజ్ రిడక్షన్. అంటే సేమ్ ఎలిమెంట్ ఈజ్ అండర్గోయింగ్ what? Both oxidation as well as reduction also. So it's an example for comproportionation reaction. Now let us go to the third example. Copper, we don't know, chlorine -1 కాబట్టి కాపర్కి ఇక్కడ +2 ఉంటుంది. ఇక్కడ ఎలిమెంటల్ స్టేట్ కాబట్టి కాపర్కి 0. ఓకే, అండ్ నౌ హియర్ chlorine -1, copper +1. ఓకే, సో +2 to +1 అంటే రిడక్షన్. ఓకే, సేమ్ లైక్ దట్ 0 to +1 అంటే 0 to +1 means what? Increase means oxidation. Same element copper is undergoing both oxidation and reduction. That's why it is an example for comproportionation reaction, in which 2 different oxidation states you are finding in reactant side and 1 single oxidation state in product side. Combination kabatti 1 single oxidation state in product side. So this kind of reactions are called as comproportionation reactions. So This is all about the types of redox reactions. Please write all the examples and practice well, dear children. Okay, thank you for watching. Keep watching my videos, keep commenting. Please subscribe to my channel. Thank you for watching. Bye.